filthy, dirty swines, get in here, sit down. Make sure you like and subscribe. But for now, let's crack on. If you are a nerd, you might know a few terminologies about the existence of aliens. You may have heard of the Drake equation, you may have heard of the Fermi paradox, all terms that orbit around the idea of if there are aliens, where the bloody hell are they? I don't know. But we have another potential solution here from the Daily Mail. An article written by the good old Mr. William Hunter. He still hasn't found his Williams yet, but he's still hunting. Is this why we haven't found aliens yet? Scientists claim looking for planets with water is pointless and say we should focus on worlds with phosphorus and nitrogen instead. Scientists hunting for life beyond Earth have long thought that water is one of the key indicators. But a group of experts now says that looking for life on water-rich planets could be a waste of time. Instead, they claim we should be turning our telescopes to worlds that are filled with phosphorus and nitrogen. Doesn't Titan have a lot of nitrogen? Life as we know it simply cannot form without these two elements, even if there's abundant water. Phosphorus is required to make DNA and RNA, which store and transmit genetic information in all life forms. Nitrogen, meanwhile, is an essential component of proteins, which are the basic building blocks of cells. This means that life can only form on worlds within the chemical Goldilocks zone, where there is just the right amount of nitrogen and phosphorus in the rocky mantle. Lead author Dr. Craig Walton of Zurich told Daily Mail you could feasibly have a planet that looks great with oceans and even dry land, but there's no life and never will be because the other elements you need are simply all but absent. So you basically need a good mix of chemicals. Water is a good solution for other chemicals to be suspended in. So if you don't have a world with water, you need some other inert medium for those chemicals to mix. So maybe not water, but water's a very good chemical for that. It's very abundant as well. So I don't know. Let's see. While no life as we understand it can survive without liquid water and oxygen, well, the plants do pretty well without oxygen. They create oxygen, but they don't require oxygen. So that's not true. Looking for planets that have these ingredients might be misleading. This is because the planet's oxygen balance at the moment of its formation determines how much phosphorus and nitrogen remain available for life. Yeah, maybe, but also you could have comets and asteroids and stuff sharing down, bringing materials. It's not exactly true. And also we have plate tectonics, which recycle to a certain extent what materials are available on the land. Who knows what's under the surface? If there's too much oxygen present, phosphorus gets locked in the mantle, while nitrogen is forced out into the atmosphere and eventually lost into space. Bloody nitrogen. Does that smell like farts? Is that what that is? Bloody farts running away into space? On the other hand, if there's too little oxygen, phosphorus binds the other heavy elements and is dragged down to the core, where it can't be used to kickstart life. Oh, I see. So oxygen is a highly reactive chemical, never really lasts in the atmosphere because it's either binding to rocks or whatever. Okay. Dr. Walton says having too much or too little oxygen in the planet as a whole, not in the atmosphere per se, makes the planet unsuitable for life because it traps key nutrients for life in the core. A different oxygen balance means you have nothing to work with left at the surface when the planet cools and you form rocks. Using numerical modeling, the researchers found that there is a very narrow band where there's just enough oxygen for both phosphorus and nitrogen to be abundant in the mantle. So this is life as we know it, though. This is not necessarily all possible manifestations of life that we don't know of, and that's the whole old chestnut of the unknowns and the unknown unknowns. There's more unknown unknowns out there than there are known unknowns, which sounds insane, but there you go. What have we got here? Cosmochemicals scatter in P plus N. That sounds very serious. Large cores, naughty. Small cores, also naughty. Earth-like, nice. I don't know. This is a band of something. Mayhaps. Why have they scribbled all over this? What is the purpose of scribbling on this part here? For mantle depleted in P and N. Peanut butter and noodles? No. Moving on. By an incredible lucky chance, Earth happens to sit right inside the chemical Goldilocks zone, ensuring that it had the right balance for other planets to form. Ensuring that it had the right balance for other planets to form? I don't understand this statement here. What do you mean? I don't think the formation of Earth and its chemical composition affected the other planets. I think that's a bit of a tripped up there, maybe. However, this likely means that habitable worlds are far rarer than astronomers thought. Dr. Walton suggests that there might be just 1 to 10% as many habitable planets as previously suggested. That might have serious consequences for how scientists search for life and how we think about the future of human space exploration. While we currently see an abundance of oxygen as a sign of habitability, the researchers' calculations suggest this may signal that the world cannot support life. It's a very volatile chemical, though, isn't it? It doesn't last in the atmosphere for very long. So if you see it, then that's an indicator of something going on, I would imagine. It would be very disappointing to travel all the way to such a planet and find there is no phosphorus for growing food, says Dr. Walton. You better try to check the formation conditions of the planet first, much like ensuring your dinner was cooked properly before you go ahead and eat it. We should probably send some probes then, maybe, wherever they are. Closer to home, the researchers' findings also suggest that Mars sits just outside of the chemical Goldilocks zone. For old Mars, it's a bit chilly though. NASA reveals they found clearest sign of life on Mars. When? What's this? Is this a alien bogey? What is this? Gross. Dr. Walton says Mars is fairly similar to Earth and its formation conditions mean there is more phosphorus, not less. This means growing food there might be relatively easy. However, other chemicals are also a lot more abundant on the surface, poisoning the soil with harsh salts. I think the soil there, the regolith, is peroxide. It's very acidic. I think all the oxygen was bound up in the rocks. Additionally, the planet has significantly lower salts of nitrogen near the surface, making it especially unsuited to life. As we know it, it's not that different, but it's not currently habitable. Elon Musk will have to come up with a clever way to change the composition to grow food there. In the future, the researchers suggest that searchers for alien life should pay much more attention to the chemical composition of exoplanets. This is very difficult to measure directly, but astronomers can get a clue by looking at the type of star the planet orbits. Since planets primarily form out of the same material as their host star, their chemical compositions are closely related. Solar systems that have similar stars to our own are therefore a much more promising place to look for life out in the universe. Here we go, the Drake equation is a 7-variable way of finding the chance of active civilizations existing beyond Earth. It takes into account factors like the rate of star formation, the amount of stars that could form planetary systems, the number of potential habitable planets in those systems. The equation includes recent data from NASA's Kepler satellite on the number of exoplanets that could harbor life. Researchers also adapted the equation from being about the number of civilizations that exist now to being about the probability of civilization being the only one that has ever existed. Right. So what is the probability of life at all? Or civilizations at all? Okay. So we're scraping the barrel now. It's not like, well, there might be 1,000 out there. We're like, well, is there less than one? Well, we are one, so there has to be more, I would imagine. More than one, otherwise why do we exist? Researchers found the odds of an advanced civilization developing need to be less than 1 in 10 billion trillion for humans to be the only intelligent life in the universe. Unless the odds of advanced life evolving on a habitable planet are astonishingly low, then humankind is not the only advanced civilization to have lived. But Kepler data places those odds much higher, which means technologically advanced aliens are likely to have existed at some point, and probably still do, somewhere. There's a lot of moons in our solar system that have cryovolcanism. Basically, instead of having liquid rock, their bedrock is basically ice water, and their volcanoes spew out liquid water. Titan is the largest moon of Saturn and the second largest in the solar system. It is the only moon known to have a dense atmosphere, denser than Earth's, and is the only known object in the solar system beside Earth with clear evidence of stable bodies of surface liquid. So you need some kind of liquid to act as a solution for chemical reactions, inert liquid of some sort. Titan is one of 7 gravitationally rounded moons of Saturn and the second most distant among them. Frequently described as a planet-like moon, Titan is 48.16% larger in diameter than Earth's moon, so it's bigger than our moon, almost 50% bigger, and 80% more massive. Okay, so it's almost double the matter and almost 50% the size. So the gravity has to be significantly more. It's the second largest moon in the solar system after Jupiter's Ganymede, which is the largest moon and is larger than Mercury. Yet Titan is only 40% as massive as Mercury, because Mercury is mainly iron and rock, while Titan is mostly ice, which is less dense. I wouldn't be surprised if there's life on Titan. I know it's very cold and the chemical composition there is weird, but I think it would be interesting if we sent more stuff there. There's a very thick atmosphere. Discovered in 1655 by the Dutch astronomer Christian Huygens, Titan was the first known moon of Saturn and the 6th known planetary satellite after Earth's moon and the 4 Galilean moons of Jupiter. Titan orbits Saturn at 20 Saturn radii. Tell me stuff about Titan, though. When viewed from above its thick atmospheric haze, it would appear 11.1 times larger in the sky in diameter than the moon. Okay. The atmosphere of Titan is mainly nitrogen and methane. Are they not indicators of life, methane and nitrogen? If you see, I think, reports of plumes of methane appearing on Mars as potential evidence of there being subsurface microbes, and Titan is choking on methane and nitrogen, so why would we not be like, hang on, that might be a sign there? Perhaps we are. It's definitely got very large lakes. What do we reckon the composition is of subsurface here? It says normal ice, not weird ice. Liquid water ocean. So maybe, I don't know, maybe there's no life on the surface, but maybe there is a lot of bacterial life subsurface that's causing or creating a lot of these nitrogen and methane chemicals that end up being pumped into the atmosphere by cryovolcanoes, maybe. Because there's a lot of other moons in the solar system that also have subsurface oceans that don't have these weird atmospheres. Why does Titan, of all of the moons in our solar system, have such a weird, thick atmosphere of nitrogen and methane, which are commonly seen as being indicators of life? Should we not kind of suspect that maybe there's a whole load of life under the surface in this ocean under here? Nobody seems to talk about Titan's ocean. They all go on about Europa. Oh, Europa's got a big ocean. But, Titan also has a large ocean and is covered in organic smudgy stuff. So, bit of a clue there, maybe. Surface temperature is about minus 179 Celsius. Bloody cold then. Not much energy on the surface, but subsurface where there's liquid water. Could there not be life there? We've got a global map of Titan. Love this shiz. Just picturing what might be going on Titan right now. Such a weird planet. Lower gravity than Earth. Much denser atmosphere. I think I've heard before if you just strapped on some wings, you could actually fly on Titan just by flapping your arms. There you go. Actual angels could be on Titan. I think there's lots of places where we should be looking for life, and the composition of that life may be quite different to what we expect. And Titan, I think, is probably the best bet. I know there's some murmurings about Mars and such, but I think Titan would be cool to send actual people to. Thank you for joining me. But that is it for now. And the only thing I have left to say is Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oinkity, squee. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinky, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 wee. snort, snuffle, oink, re-squeal, re-snort, oinky, oinkity, oink, 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 snuffle, re-squeal, snort, oink, squeal, oink, oink, oinkity, squeal, squeal, re-re-re, snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squeal, oink, 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 re-re-re, re-squeal, squeal, squeal, snort, snuffle, oink,